Hello and welcome back to this tutorial on Java and Minecraft modding. Today we are going to make our first Eclipse project. So the first thing, of course, you want to do is start up Eclipse. And here you have the launch screen. Now your launch screen probably doesn't show this here, and it also probably has a different text in this little box here. This text is a file path which points to the folder which your Eclipse project's going to be stored in. It probably says something along the lines of Documents Eclipse Workspace. You can choose whatever folder you want as your workspace. I usually create one in Documents/Kionius Drive, and I'm going to name it Workspace Tutorial because this is a tutorial. And what this workspace is, it's where all your projects are stored. Don't click this checkbox because if you want to switch workspaces, it makes it really hard to. And now that you've created your workspace folder, you can click Launch. Edit this part out because it's boring. Oops. Okay, so now your Eclipse screen is going to show this thing called welcome. It doesn't really provide any useful information. I mean, if you want, you can click some of these links like tutorials, but this is already a tutorial, so you don't need that. So there's also a checkbox down here which says always show welcome at startup. Uncheck that because it'll be really annoying when every time you open your workspace, it shows this. So you can close that quickly. You don't need the robot console down here. And these tabs, this is where your console is going to appear. And your console is basically a little line of texts which will show what your program is doing. And we'll go over that later. The Package Explorer over here is where you create your actual Java project. So you can either right click here and click New Java Project, or you can go up to this little icon and click Java Project. So I usually right click, so I'm going to click New Java Project, and I'm going to call this one Tutorial Project because it's the tutorial project. So now this is your project in the Package Explorer. You can have as many projects as you want, so I can create another one called Example1 Project. And they'll all appear here, and they get stored in the file system on the folder, which is called your workspace name. So if I go to Documents/Kionius Drive /workspace tutorial, you can see the two file projects here. And there's a thing called metadata. That's basically just, it's exactly what it sounds like. It's metadata for the Eclipse workspace. It's all the information about your default settings in the workspace. For example, I'm just going to quickly delete this project here. And you can delete project content on disk to get rid of it in the actual file stream. Because if you don't click delete project's contents on disk, when you delete a project, it's not going to delete from the actual file stream, which means that it's still going to exist on your computer. And of course, sometimes you don't want to delete the project completely. You just want to make it disappear from the workspace. But I'm going to delete it from the disk because I don't need the Example1 project. So anyway, one thing you want to do is create something called a class. A class is basically a unit of a program. A class is the file where the program will run, and you need a class in order for anything to happen in a Java program. So I'm going to create this class called Hello World because we are going to use the Hello World project. And over here in this project, we're going to write something called public static void main string double brackets. So the square brackets on the keyboard, they're right next to the P key for a typical keyboard, and args. And what this is it's the place where the actual program will run. So basically in this little thing called static void main string list args, it's called a method, by the way, you can write lines of code, and the computer will start from here and it'll go down line by line, executing each line of code and doing stuff. So right now, because this is our Hello World project, which is kind of a programmer tradition to start with a project that prints out Hello World, we're just going to write system with a capital S because Java is very case sensitive. If you don't write a capital S, you're not going to get the right effect in your program. And dot out dot println opening parentheses, so shift +9 quotation mark, and Java automatically will complete the ending quotation mark and ending parentheses. This can be annoying sometimes, but it's also very helpful. For example, you don't have to actually write the opening ending quotation mark ending parentheses here. So then just write hello world, spell it correctly, of course, or whatever you want. You could write hello pineapple or hello Cthulhu. So hello world is a programming tradition to write here. And if you put a semicolon at the end, that will indicate that this is one line of code. In Java, enter signs, spaces, they're not super important. Like I can put spaces here, I can put spaces here. Of course, I can't put spaces in this because this is a name. Then it'll give an error. But around punctuation, the amount of spaces never really matters. So you need a semicolon to indicate this line ends. And now we have our first program, which is the Hello World programming tradition. You probably don't really know what the rest of this does. Like I explained that this is gonna print out the text Hello World, which means it'll appear down here.
Later.
But the rest of it I'll explain. Okay, so usually you can, if you've run the program before, you can go up here and click run. But since you've never run the program before, you have to do it a different way. You have to right click on the file which you have the main method in. This is the main method. And any file which has the main method is the entire program. So the program will only run using this main method. If you have multiple main methods, you have to specify which main method you want to use. So you right click on this file, you click run as one Java application, and this thing called console will appear down here, and in it, it'll show hello world, because that is what the system.out.println method does. It shows a little text saying hello world. And then the fact that it says ln here is the equivalent to the enter key. So here, because it says ln, it's like pressing an enter key. If you wrote system.out.println hello world, my name is Cesar Chavez, you could right click this and click run as one Java application, and it would say hello world, enter key over here. My name is Cesar Chavez, enter again. So yeah, that is our first program, hello world. My name is Cesar Chavez. So we've got this line of code. I changed, by the way. And that's a simple line of code. It's just an output. It just shows something down here at the bottom of the page. So it's not a very interesting line of code as far as lines of code go. So let's try with an input. Now, inputs in Java are kind of a complex process. So we're gonna have to explain a few things. No, I'm gonna have to explain a few things. So the first thing I'm gonna explain are variables. Variables kind of like a box. It's not like a variable in math. Those are they're similar but pretty different. A variable is a box which can hold a value, and while it has that value, you can use the variable to access the value. So if you have just like, it's just a box, you can put like a number inside it. So 2. So now this 2 is stored in the RAM, which means random access memory. Random access memory is like the memory of the program down here, which is storing everything the program does and then gets totally deleted once the program ends. So variables get stored in RAM, and they get stored between these curly braces. So if you make a variable anywhere in this curly brace area, it'll be deleted at this ending curly brace. A curly brace defines what is known as a scope, which is an area where a variable can exist if a variable does not exist past this curly brace. So you can't find the variable here because it gets deleted off of the RAM, which is down here, just holding variables. So a variable is a bucket. That's all well and good. And what it does is it allows you to A, store the value, B, change the value, write the value, or C, read the value, access the value. So say you make a variable int, which is the type of variable. Int is an integer, which means a number which has no decimal points. So -1, 0, 1, 2, etc. So you need to give the variable a name. So we will call it number, just number sign. Then you put an equal sign. So an equal sign in Java is a bit weird because when you put one equal sign, that indicates basically that you're putting what is on the right side, into the variable on the left side. So this is called declaring a variable, which was when you write the name of the variable and write its type. And when you put the value inside, so 6, this is called initializing. Remember, a Java line always ends with a semicolon. If you don't put a semicolon, it's not considered a line and it'll give you an error. See? This little red X, by the way, means error, bad thing. So anyway, if you have this number here, you can change it later on. So if you write number, remember, don't write int in front of it because int is called declaring. When you write int, that's when you create the variable for the first time. If I just write number like this, that's accessing the variable. So I can't just put a semicolon here because I have to actually do something with it. The Java is going to be like, why are you just writing the name of the variable here? You have to actually do something with the variable. So I can change the value of the variable. I can change number to 7. I can even change number to what it was before with additional value added. So if I do number equals number plus 3, first of all, this is not just going to create an error because you can actually access the variable number in itself. Because this line, this side of the equal sign runs before this side of the equal sign. So 7 is created before a number and then put inside of number. In this case, number is 7 here, right? Because remember, line of code runs from top to bottom. So this goes, and this goes, and this goes, and this goes. So number is 6, now number is 7. Now this is 7. This little this number, imagine that this just says 7. It's the same thing because a number says 7. So you can do number plus 3, which means that this variable will now have a value of 10. And I can prove it. So you know the system.out.println. Well, you can actually just write number in here because system.out.println can write numbers to the output. And if you do that, it'll show you what exactly number is. So we expect number to be 10, right? Unless I did my math wrong, but I hope I didn't. So that means that here it says 10 because I set number to 7, then I added 3 to it. 7 plus 3 is equal to 10. You can create multiple variables, so I can create another int number 2, or I'll just call it digit. Synonyms. Not exactly. But int digit is equal to 12, which is kind of a misnomer because 12 is not a digit, it's a number. But anyway, we're just going to ignore that for now. You can do digit equals digit plus number. And that way, oops, semicolon, always remember the semicolon. That way, digit, because number is now 10 and digit is now 12, digit will be set to 22 because here is 12, here is 10, and therefore digit is 22. System.out.println digit should say 22. Of course, remember, this line of code runs first, then this line of code. So it'll print out number, which is 10, and then it'll print out digit, which is 22. And of course, with an enter sign in between them, because ln here means enter sign. Now, I keep saying ln means enter sign, but that means that there should be something which does not mean enter sign. If you just take away the ln here, it'll print it without an enter sign. So if I run this, we get 1022 because you print out the 10, no enter sign, you print out the 22. No enter sign here. But it's better practice to do print ln because it looks ugly otherwise generally. So I told you about the int and that it's a number without a decimal point. Well, in Java, there are these reserved words. They appear in purple, like public, static, void. And some of the reserved words are int, double, long, short. As you can see, they're all turning purple. Boolean, float, and char. I mean, it's short for character, so you can pronounce it care or char or car or whatever you want, but I'm just gonna call it care actually, not car. Or should I call it car? Car sounds better. Okay, so these are called primitive types. Basically, you can create a variable car character equals a, because that's creating a variable called a. So what these are, primitive types, is basically just things you can write in front of a variable name to turn into a variable. If you write float x equals 5.0, you've created a float variable which is called x, and it's giving a lot of errors because you can't just write reserved words in a list like this. So I'm just going to delete them. You don't have to memorize them or anything. It's good to know them all, but I'll go over them individually. And so what these are is just, well, they're all different types of data which take not a lot of memory to store. A Boolean is the simplest. A Boolean is 1 or 0, true or false. So Boolean, can I eat, is equal to true, I am allowed to eat, or false, I am not allowed to eat. Booleans are simple. They are just 1 and 0, true and false. 1 means true, 0 means false. You don't actually have to write 1 or 0 in the program, but in the memory, people represent the Booleans as 1 and 0 because that's how the memory stores things. It's basically, the computer memory is just a bunch of like magnets or capacitors which all have a state which is full of energy, or I guess North Pole or whatever, and empty, and that's 1 and 0, or true and false. This is an entire counting system called binary, where you can make every single number using 1 0 1 0 1 1 1 1, where 0 is 0, 1 is 1, 1 0 is 2, 1 1 is 3. It's not something that I'm going to explain now because it's not really something you need to know, but you can keep that in mind if you like. So the next thing that I'm going to tell you about is, well, actually I forgot to write it, but byte. Byte it's a number without decimal points that takes a really little memory to store. So byte b equals 1, 2, wait, I need a semicolon, 5, 4, 7, 8, 9, 10. I think bytes only store up to 255, so I think 256 would cause an error because a byte can only store up to 255 in terms of numbers. So a byte is just like a number that has a very little memory. The upgrade to a byte is a short, which can store a little more. I'm not sure what the max value for a short is, like 1020. No, I don't know. I'm not sure what the max value for a short is, but a short is a number without decimal points that can store a little bit more. An integer is the most commonly used one. An int is a number without decimal points, like -1, negative 16, for example. It can store from like negative 28 something. I forgot the whole number. It's you can write integer.max value if you want to see it. It says 2 to the 31st minus 1. But anyway, an integer can store up to 2 to the 31st minus 1 in numbers, and that's its max value. Then you get a long, which can store even more. So a long can store up to 2 to the 63rd minus 1. Of course, it takes more memory than an integer. So you should only use a long if you might have a lot more than 2 to the 31st minus 1 in your number. The funny thing about integers is that if I write int z equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, something like this big, you can't store it. If I do a calculation, so like 23 to the power, not to the power of times 2, 3, 7 something, that's too big, times this, okay, still too big. Are you serious? Okay, so this, if you do this number calculation, it'll actually cycle around. So if it gets too big, if it goes over 2 to the 23rd minus 1, it'll become negative. It'll go down to the negative 2 to the 23rd minus 1 and then just add the remaining. So basically, try to avoid using big numbers with integers because Java can't hold big numbers in integers. And if you try to do calculation which is too big, Java will literally just cycle the integer down to the lowest number and then redo it from the lowest and go up. So you can use a long for bigger numbers and it will be less likely to because long goes up to 2 to the 63rd minus 1, which is a very big number, which I'm not going to show you because I don't think that I need to do that. So then we get to something called double. The double is it's got a lot more memory than an integer, and basically it's got a strange name. But all double means is like a number with a decimal point. So you can write 12 if you want to, because technically 12 has an implied decimal point. It's 12.0. You can write 12.0 if you want to. You can write something point. Oh, you can't put an L in there though. That's a bad idea. You can do that. You can even write it with scientific notation, but scientific notation in computers can be gets written a bit weirdly. Instead of times 10 to the negative first, so like instead of doing 10, and you can't exactly do a superscript here, you would have to do e and then the power of 10. E just means times 10 to the negative first. So you can write any value in a double. Double is the big memory value. So double dot max value is equal to a really big number, as you can see. 2 minus 2 to the negative 52nd times 2 to the 1023rd. Is that a big number? That is a big number. Here it is. 1.79769 blah, 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 blah times 10 to the power of 308. So doubles can hold a lot of values. The thing is though, in a computer, doubles are stored with scientific notation. They'll have one integer which stores this number, then one integer which stores the power of 10, which it goes down to. So blah, 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 times 10 to the negative 324/5. There's one number which stores the first part and one number which stores the power. So doubles actually lack precision, unlike integers, which are forced to be precise. Then you can go down to something called a float, which is just a double that takes up less value, less memory. So like up to a certain point, a float can't hold the number anymore. Oh, that's not what I meant to do. Like, I'm not sure entirely what the max and min for a float are. But the funny thing about float is that since it takes up less memory, if you write a double number in it, like blah, 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 you have to put an F at the end, because this F means it's a float. Because since a double can potentially take up more memory than a float, it has to put this F to know, oh, we're putting a double in here, so if this takes up too much memory, we're gonna have to turn it into something that takes up less memory. That's what the F signifies, basically. Now, in a Boolean, even though technically it's a 1 and a 0, so it's an integer value, you can't just write a number in it. Like, that doesn't work. You have to write true or false. Now, numbers, of course, can be mathed. You can do int s equals 234 plus whatever this is. Looks like they're too big. Oops, forgot. Integers are tiny. Yeah, you can do this. Double ASDF. I don't know why I called it that. It can be this plus that. That's addition, believe it or not. Plus sign. You can also do int d, difference, is equal to this minus that. You can do double d2 is equal to this minus, oh my god, this. You can do multiplication, you can do division. So there's a funny thing. Division works strangely, shall we say. Integer division is, I guess we'll call it, it's kind of like flooring. It's like, you know how you do long division, you write out the number and then you write out the, well, not long division, but just division. When in elementary school, you write out the number and then you write out the remainder. Well, in Java, if you want to divide two things, you have to, if you have to divide two integers, your resulting value automatically gets turned into an integer. What that means is that 12 divided by, I'm going to choose a nicer number. Actually, 10 divided by 3, you'd expect that to be 3.3333333 infinitely repeating. Obviously, computers don't have infinite memory, but so you can't make an infinite repeating decimal, but we won't go over that right now. 10 divided by 3 will actually become 3. Oh, by the way, you can't write equal signs like this. This is bad form. But it will become 3, not 3.333. I can prove it because of system.out.println. It just becomes 3. Now, why is that? Like I said, this is an integer variable. You can't put a decimal point number in it. See, look, you can't just write 10.3 because then it'll give you an error. You can't convert from a double to an integer. So what it does is it just turns it into an integer. If any time that any of the two things being divided are integers, it'll turn the value into an integer. Now, if you want it to be a double, you could just put a 0.0. First of all, of course, you'd have to make this a double variable because you can't just have an integer variable holding a double. That doesn't work in Java. Integer variables are intended to hold one type, which is integers, and you have to put one type in it. Double variables can hold integers or doubles. Now that we've done 10.0 divided by 3, it'll work as intended. It'll divide it by 3, 3.233. This 5 at the end is because it needs to round, and obviously, like, a computer can't hold an infinite number of 3s because it's not like a magical thing that can just hold forever. It needs to round at the end, and this also gets into a topic called Roundoff error, which we'll talk about a little bit later. So you might be wondering when I said that something about division, remainder, and quotient. 10 divided by 3 in integer division. Oh yeah, by the way, if you store 10 divided by 3 like this in a double variable, it'll still give you 3.0 because this is an integer and this is an integer. So like I was saying, I said quotient or remainder. Well, you can get the quotient using 10 divided by 3. That'll give you 3 because 3 is the amount of times 3 goes in 10. What if you want the remainder? Well, the remainder you can get by using something called the modulus operator. I think the verb is modulo, so I'm 10 moduloing 3. That sounds weird. Just say modding. 10 modding 3. So 10 mod 3. Mod is represented by a percent sign. 10 mod 3 is, let me think about this for a second, 1. because 3 goes into 10 3 times with the remainder 1. So what int it should be is 4 because 3 plus 1. So now it's 4 because 10 modulo 3 is the remainder of that division. Now, modulo also works with decimals. It's like you can have a decimal remainder technically if you want to. So 10.11% 3.1. Oh, of course, you have to change this to a double if you want to include like double values in it. Yeah, so you should probably avoid saying things like, oh, I'm going to make double the programming or something because double already means something in Java. It's a reserved word, in fact. So yeah, like I said, 3.1 goes into 11 3-ish times and has a remainder of 1.699999 and then just have like a 7 at the end because of roundoff error. Now we're going to talk about roundoff error. Roundoff error is when you do like 11 divided by 56.0, of course, because you have to make sure it's a double. If you do 11 divided by 56 without the double, it'll just become 0 because 11 is less than 56 and the remainder of the division is 0. So you have to put 0.0 because that'll make the double. 11 divided by 56.0 is probably a very annoying number. So when you, well, actually, this is not going to tell us much. Okay, let's try it instead. 11.0 divided by 12.0 divided by 6.0. Now, this should just result in 2. There is a small chance, though, that it won't. I'm not sure if I can get it to happen. No, apparently not. Well, basically what it's called is roundoff. Roundoff is like, it looks like a random value just stuck to the end of a division quotient. Well, a division quotient. So if I like I did 10 divided by 3. So you would think 0.33333, and at the end it would round to 0.3 because 0.33 it would round to a 3 because, well, 3 makes the one in front of it go down because it's less than 5, etc., etc. But however, there is something called roundoff error, and that's this 5 at the end. Now, roundoff error is kind of random. It might not be a 5. It could end up being like a 1. And if you will show me a 1, thank you. Okay, so it's not showing me that. But it could end up being a different value, and that is something that is very annoying because it can introduce all sorts of uncertainty into your program. So with doubles, you have to be a bit careful when you're using them in your program because 10 divided by 3 is not 3.3333, it's 3.3335 because of roundoff. So now with all these lovely big numbers, we should maybe do something that asks the user for input and prints it out the addition of 2 inputs. So first of all, system.out.print, because we don't want a new line, type your number. Remember to always put quotation marks. Quotation marks are what's called a string. They indicate a bunch of characters, which basically aren't like Java code, but just literally just a bunch of letters. And it's like quotation marks, like in a book, it shows a dialogue. Well, in Java, it shows literally anything that's wordy and doesn't mean something special in Java. So if we do system.out.print type a number, and then we have to do this thing called scanner. Scanner scan is equal to new scanner system.in. So you'll notice it has a red underline. That's because scanner is what is called a class. It's a type. It's something that you have to import, which means you write at the top of the class file. It has to be at the top because if you put it like, you can't just write import here. That doesn't work. Import is a reserved word, by the way. So you can't just call a variable import. You can't make a method name import. Import, what is this? Java.util. And then dot scanner, because that is what we want to import. Now there's no error because what import does is basically it says, oh, java.util.scanner shall now be called just scanner. Technically, I can just write java.util.scanner and I'd have no errors because that is technically the scanner's name. Scanner is called java.util.scanner. It's kind of like there might be like a Stacy Oaks living in a house somewhere around here, and there might be another Stacy Oaks living in a house somewhere in Missouri. Well, if you write send this to Stacy Oaks 1532 something street. I forgot the abbreviation for Missouri. Is that like, you know what? I'm not going to think about it. So yeah, you can do that, or you can just do, or you can tell a friend who knows who Stacy Oaks is, send this to Stacy Oaks. And importing is like it's like a friend who's like, oh, well, I know what a scanner is, so I'm gonna say that you don't have to tell me to send it to java.util.scanner because java.util is like an address. You don't need to tell me that. You can just tell me to send to scanner and I'll know what you're talking about. So basically scanner is a class which is in the folder java.util, which is in this thing called the JRE system library. So if we go down to, actually java.util does not exist in the JRE system library because it's something that's intrinsic to Java and is therefore like an important part of Java. But anyway, this is like telling it the address. This is telling Java the address of scanner so that you don't have to write out the entire address every time you want to use it. So scanner is a class. Like I told you how you can declare a variable by writing int name equals value. Well, scanner is what is called an object, and we're going to go over that sometime. An object is basically just anything in Java which interacts with other parts of Java and does something. So now we're going to, because I created a scanner here called scan, we're going to do this thing. We're going to create a variable. So what we want to do is int num1 equals scan.next int. That will so basically this is called a method. A parenthesis indicates, like here, that you're running a method. If you put a parenthesis at the end of something, it's either a method or a constructor, but we're going to go over constructors some other time. So a parenthesis will indicate that this is a method. And what you're doing is scan is the object. Next int is something that it can do. It can get an integer from the user when they write down here, like blah, 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 down here. If they write a number, scan will take it using next int and put it inside of num1. Remember I told you that this is how you set a variable. You write the name, the type, the name, and the value. Well, the value always runs before the setting. So before it's set to num1, scan.nextInt will run. And that will put scan.nextInt in num1. So nextInt runs. It will give back an integer that the user typed down here, and then it'll put inside of num1. Of course, if the user types like letters or something, the program will crash. And I can show you that if you want, but not right now. So then we can have int. We can do, I'll just copy paste it. Copy pasting is a programmer's friend. Remember this. Type your second number. And now you don't have to recreate a new scanner for every line. You can just keep the same scanner and just do scan.nextInt again, and it'll just give you the next int. Because scan exists in the memory, so scan is an existing object. And remember I told you that variables are declared inside of a scope? Did I tell you that? Well, variables are declared inside of something called a scope, which is determined by these curly braces. And scan, once we reach the second curly brace here, scan will vanish forever and ever and ever. It'll never exist again, which is probably sad. But that means that you can, scan exists within the curly braces. So anywhere in the curly braces, you can just reuse scan all the time, unless scan is null, because null is what is known as, it's literally null, it's no value. If scan is null, that means that it's got nothing inside it, and anytime you try to call a method on it, since it has no object inside it, it'll return what's called a null pointer exception, which is an error, which is like, oh, there's nothing here for me to do anything on. Like, a car that does not exist cannot drive. The same way, an object that does not exist cannot use a method. A scanner that does not exist cannot accept a next int. But we're not going to set our scanner to null. That's a stupid idea. Why would we do that? So we are going to keep a new scanner. Null can be useful, but not for this. So now that we've got two integers, we're going to print out out.println. The sum of these integers is, and then you can do this thing called concatenation with strings. It's got nothing to do with cats or conches. It's basically where you put a plus sign. It's got nothing to do with addition either, by the way. And then you can write anything else. So like num1 plus scan if you wanted to for whatever reason. And basically what this does is turn num1 into a string. So it turns this integer into a string. That's called casting, when you turn one type into another. Concatenation isn't exactly casting. It's more like putting the integers part of a string. But what this is doing is it'll print out this, and then it'll print out num1, and then it'll print out num2. Now, the problem with this statement is that here, the plus sign means addition. No, I mean, it means concatenation. We wanted it to mean addition, but it means concatenation because this plus sign means concatenation. So since this turns into a string and Java executes from left to right, this will be a string, and when you add this, this will be added to the string. So it'll just print out some of these integers, and then it'll print out the integer and then the next integer. So we don't want that, so we just do parentheses. Like math, Java executes parentheses first. So the first thing it'll do is add these together. Then it'll go from here, add this to this. So the plus sign has two meanings. It has concatenation and it has adding. This is adding because these are both integers. And this is concatenation because this is a string. A string automatically takes precedence. If you add a string to anything, it'll automatically become a string. However, of course, this happens in order of operations. So num1 plus num2 plus the sum of these integers is, it'll first add num1 and num2 to get the sum of them, and then it'll stick it to the from beginning of this. But plus signs in general can be used to insert integers into, not integers, insert variables into print statements. And you remember to put a space, otherwise it looks ugly because it's not going to automatically add a space. It's going to want you to put a space. So now we have a little program, and this is called a warning. It's when Eclipse tells you something that's not of great importance, but is kind of might be important. It's telling us to close the scanner. We don't really need to do that, but how you close the scanner is by doing scan.close. And if you close the scanner, you can't do next int. If you try to do next int on a scanner that's closed, it'll give you an error because when you close the scanner, that means you've stopped using it. Java is gonna like throw the scanner into the box of closed scanners and be like, well, you can't open this anymore. Shuts the lid. And if a scanner is not open, it can't accept more integers, so it can't do anything. So now let's run our little program. Type your number. Well, I could just type like blah, 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 and then it'll give an error because it's not an integer. Oops, go away. It's not an integer, and you need an integer. Let's redo that. So now what do we want to add? Well, we can add 42, the meaning of life, the universe, and everything, and 1, number of horns on a unicorn. Some of these integers is 43 because we added them together here. So that is how you make a simple input-output program and do math. We will go over objects in the next tutorial. But anyway, yeah, that is the end of this tutorial. Goodbye for now.